Hello, I would like to introduce ourselves. We are students of Georgian American High School. I am Sekhme Gogrichian.
Salome Peridze.
Lia Razmadze.
Georgi Gystb.
While investigating three-dimensional shapes, we were interested in regular tetrahedron. We found material regarding this at Alex Bogomolny's site, www.katzig.org, a site filled with numerous interesting theories about algebra, geometry, calculus, and many more. We looked through the theories in our area of interest, geometry, and came across theory number 157, concerning an identity for regular tetrahedron. This theory proves that the sum of the squares of the distances from the vertices of regular tetrahedron to the point on its circumsphere is constant. This theory uses spherical coordinates, and we prove the same using Cartesian system. We also prove that the sums of the fourth power of the distances are constant, and the point can be on the surface of any sphere, the center of which is the same as the center of tetrahedron. We also tried to prove similar hypotheses for the seed powers, but sum was not constant.
We introduced a Cartesian coordinate system so that the coordinates of the vertices of a regular tetrahedron are T1, T2, T3, and T4. The origin of the coordinate system is chosen to coincide with the centroid of the triangle T1, T2, T3, and X and Z axis passes through the vertices T1 and T4 respectively. Then the centroid of the tetrahedron is O. The equation given is the sphere equation with center at the centroid and any radius L. The circumradius of the tetrahedron is R. The square distances from an arbitrary A point to the vertices are given below. And the sum of the squared distances, as you can see, is 4 times L squared plus R squared. The sum of the fourth power distances, however, is fully dependent on X, Y, and Z coordinates, which we tried to write only in terms of L and R. By using identity formulas, we tried to simplify this equation, and we came to the conclusion of
the sum of the fourth power distances from an arbitrary point on a sphere with the center at the centroid of a regular tetrahedron to the vertices of the tetrahedron is constant and is given below, where L is the radius of the sphere and R is the circumradius of the tetrahedron.